New idea number 2. So we've already learned the general solution, which wasn't so bad. New idea number 2 is what happens when there's a value inside of our function. And so this one has a horizontal compression of 1/3. I give these questions a name because sometimes if we give things a name, it's easier to remember how to do them. I call these questions multi-revolution questions. Okay? It's a multi-revolution question because instead of just solving, for example, in this one, normally we solve from 0 to 2 pi. So if 1x is between 0 and 2 pi, what is 3x's between? Okay? Now, if I got you to pick a number between 1 and 10, okay? You could pick any number between 1 and 10. Now, if I got you to multiply that number by 3, what would all of these numbers be between? If you pick between 1 and 10 and I multiply by 3, would there be anybody who had a number less than 3? No. The smallest you could have would be 3 then. And what would be the biggest you could have? 30. So if you pick a number between 1 and 10, and then that gets multiplied by 3, your new numbers would be between 3 and 30. Okay? So if we start with a question that says solve between 0 and 2 pi, but instead of having an x inside, we have a 3x, that 3x will be between what and what? It'll be between 0 and 6 pi. And 0 and 6 pi is like going 3 times around the circle. That's why I call it a multi-revolution question, because instead of going once around the circle, we're going to be going 3 times around the circle. How do we solve multi-revolution questions? You skip them. No. You solve them like normal. So if it was just sine theta equals 0, so we have sine 3x equals 0, but if you just had sine of theta equals 0, how would you solve that? You would say, is 0 on my pi plate? Yes. And when is it equal? When is sine equal to 0? 0 and pi and 2 pi. So you would write 0 and pi and 2 pi. And normally when you have sine theta equals, what would you write over here? Theta equals, right? But instead of theta, what do we have? We have 3x. So we write 3x equals 0, pi, and 2 pi. But this is where our multi-revolution comes in. Okay? Where do we have to, if we're solving for 3x, we have to look between 0 and 6 pi. So are these all the answers? No. We would have 0, pi, 2 pi. That would only be the first time around. The second time around, you would also have 3 pi and 4 pi. Correct? And the third time around, you would have 5 pi and 6 pi. Okay? That would be 3 times around. Now, I just noticed a small thing that's different. So I take out my small eraser. Notice that they wrote 0 less than or equal to x less than 2 pi, and I added the equal sign. So, oh, I like that little eraser. So then 6 pi isn't in it. Okay? Oh. Oh, I like this little eraser. Oh, that T should be a little lower. That T looks there. That looks so much better. Okay, sorry. You got a question. Go for it before I erase everything. Why is it 3x equals 0 pi? Like, how'd you get there? Well, because normally we have a theta in that green box, right? Oh, yeah. And so normally when you solve, you say theta equals. But now, Whatever's inside the box, which would normally be theta, we have that instead. So now we have 3x equals. Now the question didn't say solve for 3x. The question is getting us, what do they want us to solve for? They want us to solve for x. So in a multi-revolution question, the first thing that's different is your domain gets changed when you're looking at 3x from 0 to 6 pi, so it's 3 times around. And now once you have figured out what 3x is equal to, you can now figure out what x is equal to. How would I get x by itself? I'd have to divide everything by 3. So the first answer gets divided by 3. Our second answer gets divided by 3. Our third answer gets divided by 3. Our fourth answer gets divided by 3. And in the end, can you see, we got 6 different answers. Can you see that all 6 of those answers are between 0 and 2 pi, which is what our original domain was supposed to be. So for multi-revolution questions, when you're solving between 0 and 2 pi, you multiply by whatever's inside. So if it's a 3x, you multiply by 3. If it's a 2x, you multiply by 2. And you have to go around more times than once. Find out all of those answers. Once you've found out those answers, well then, in this case, we had to divide by 3 to find out what x is equal to. So those are all the answers between 0 and 2 pi. For part B, it says, what's the general solution? So now we're combining the first new idea from today with this new idea. How did we find general solution? We wrote 2 steps. Step 1 was solve between 0 and 2 pi. Have we done that already? Yes. Step 2, you add 2k pi to all of them. So your final answer is going to look like this. Whoosh. How's that? How many answers do we have? 0, pi over 3, 2 pi over 3, pi, 4 pi over 3, oh, got to scroll down, and 5 pi over 3. And what do we have to do to each one of them? Plus 2k pi, 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 plus 2k pi. Okay. Whoever's watching this as a video is going to be like, oh my goodness. Okay, sorry about that. Where k is an integer. Whew. There is a nicer way, but it's confusing for some people. So, okay, so I find that this is the least confusing way. You got your general solution where you solve between 0 and 2 pi. And once you solve between 0 and 2 pi, then you add 2k pi to each of them. I will show you the second way. Okay, and if you like it, you can use it. If you want, you know, a lot of people like this because they solve between 0 and 2 pi first and then add 2k pi. That's fine. But I'm going to show you how would I solve sine 3x equal to 0 if this was the question originally. I want the general solution originally. Well, it's kind of the same idea. I solve between 0 and 2 pi by going 3x equals, what are all the answers for sine equaling 0 from 0 to 2 pi? That would be 0, pi, and 2 pi. 0, pi, and 2 pi. Okay? Then if you added 2k pi to each of those, that's what it would look like. So that's like imagining I just had, whoa. I just had sine theta equals 0, where theta is a real number. That's how you would do it. And you might even realize that you could write those shorter. Does it make sense that I could write those all together as just k pi? Because you would have 0, pi, 2 pi, 3 pi, 4 pi, 5 pi. I could write all of those together as just k pi. Okay? How do you solve for x? Divide by 3. So either, some people might not realize this shortcut for the k pi. If you didn't realize the shortcut for the k pi, then you would write x is equal to each of those divided by 3. Now, when you divide it by 3, you'd have 0 divided by 3. You wouldn't have to write that because you probably know that that's 0. Plus 2k pi, that gets divided by 3 as well. You would have pi over 3 plus 2k pi divided by 3. And you would have 2 pi over 3 plus 2k pi over 3. Still k is an integer. If you realize the shortcut, then this answer just becomes so that's the most elegant answer because it's so pretty and short and compact, k pi over 3. What would k pi over 3 include? 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3, 7 pi over 3, and so on and so on and so on and so on, plus all the negative values. And if we think about that, is that not what we had right here? No pi over 3s, 1 pi over 3, 2 pi over 3s, 3 pi over 3s, 4 pi over 3s, 5 pi over 3s. So we just wrote it in a nicer, shorter way. So those are two ways that you can solve for multi-revolution questions that are also general solution. I would recommend to keep things simple, solving between 0 and 2 pi first, and then you can add 2k pi. Yes, our answer here is clunky. I don't know if clunky is a good adjective for answers, but there's a lot of it there, a lot of extra information. It's not as elegant as this answer here, but this is another way of solving it. So you get to decide how you want to solve it. In method 2 here, I solved it like a general solution first, and then divided by 3 afterwards. The other way, I solved it as a multi-revolution question first, and then did the general solution afterwards. Questions that are multi-revolution questions that we're going to work on right now. 5, 6, and 10.